Hello community, so great that you are back. Today we look at the best LLM on this planet and we go here and we go for the overall just to give you a general impression. And we have here, number one is Gemini 2.5 Pro from March 25. And we have number second is ChatGPT 4.0 from March 26, the latest update. Yesterday, ChatGPT has been updated, the 4 Omni version. Then we have Grok 3, GPT 4.5. DeepSeek R1 is ranked number 7, beautiful, and then O1 and Q1 and Gamma and whatever. But we are interested in mathematics. No, we are interested in logic. We want to know a system that is really able to think. Gemini 2.5 Pro. What a coincidence. Oh, GPT 4.5 and DeepSeek R1. This is now an interesting combination. DeepSeek R1 even before the O3 mini high. Okay, so those are the data. And you want something else? What else do we... Instruction following. Yeah, let's have a look at the instruction following. The best model is Gemini 2.5 Pro, GPT 4.5, ChatGPT 4 Omni, the latest. Wow, this latest update, the AI community who voted for this was really impressed with this, although we have quite some in trouble, but whatever. What else do we have that could be interesting? Multi-turn conversations, absolutely. Wow, here we have, okay, number one, and number one. The first 3 share here, rank number 1. GPT 4 Omni, GPT 4.5, and Gemini 2.5. Is this true? I mean, this is just the global AI community. I mean, what is this compared to our beautiful logic causal reasoning text? Let's jump right into it. So here we are now, beautiful, and I have here Gemini 2.5 Pro Experimental, March 25. I go with this one. I don't change the temperature. This is the default temperature. I do not allow structured output, no code execution for the moment. I just want to see the inherent logic, no function calling. I want that this is an inherent logic test. And you know what we're gonna do? No, we have my elevator test. You are trapped in a skyscraper. You want to reach floor number 30. And you have 5 buttons, A, B, C, D, E. And the challenge is, what is the shortest path? And you have 2 trap floors. This is the same thing I do here for, I don't know, 11, 12 months now. Yes, I want to see you thinking. Okay. BFS, we have a mathematical methodology. Nice. You see, it's not trying out like other systems, just try. It decided for a methodology and it is dequeuing. No, it is really dequeuing here. 3, 4. Yeah. Oh, wow. This is a linguistic dequeuing of BFS methodology without Python code or C++. This is coded in English. This is a syntactic language encoding and a dequeuing and an enqueuing. This is self-correction refinement during the process. Nice. Collapse. This was the sort, and now we have an answer. Okay, I just let it run through, and then we have a detailed look here. What's happening? This is impressive. Level 2 dequeuing. ABCD, dequeuing, ABCD, ABCDE, level 3, current floor. If he manages to get through without any mistake in the causal reasoning chain, this is the right path. This methodology is a winner. Hey, continue dequeuing. Hey, solution found. Let's have a look at this. Okay, this looks too good to be true. Step-by-step explanation, solution found. BFS algorithm, the correct algorithm, great. Since BFS guarantees finding the shortest path in terms of step, this system was able to do this here in linguistic terms. AB, AA, BD, this could be it, number of presses, 6, this is the number of minimum presses. Step-by-step explanation. I mean, it looks real correct. This is not possible. But there was something. No, you are not gonna fool me, my friend. Wait a minute. So here are the sorts. Beautiful. Choose a strategy. This is the shortest path problem on a graph where floors are nodes and button presses are edges with specific rules. Correct. The graph is implicitly defined. Yes. We want the shortest path. The breadth first search BFS is the most appropriate algorithm. Correct. This thing understood the constraint, understood my goal, came up with a strategy before doing anything at all, set up a correct mathematical Python algorithm, not in Python because you see code execution is not allowed, and it started to execute this in linguistic terms. It started to dequeue current floor path, yeah, and then it went through all the combination, button A, button B, button C, button D, button E, dequeuing, yes, A, B, C, D, E, dequeuing 3, D. It is really going through all the possible combination. This is impressive. You know, none other system ever managed to do this because there was somewhere a hallucination, somewhere there was a mistake, somewhere the numerics did not add up, somewhere some algorithms were confused. But this causal reasoning chain is absolutely impressive. But hey, look. Q, okay, no, this is just, okay, no, this is correct. Sorry, I thought that he was not really doing this, but I understand what he's trying to indicate here, yeah. DQ19, it really went the shortest path. This is the first time that I see this in an AI system. I mean, everybody can go and say code execution and it writes here a Python program or a C++ code. But this is goal reached. This is so nice. Come on. Solution found. Verify the path. It did an internal verification. Check the trap floors. No, this is the correct way. Check optimality. BFS guarantees that the first time a node is reached, it is via the shortest path in terms of the number of edges. So we have a graph algorithm. This Gemini 2.5 Pro, nice. During there's another, I must have said, therefore it is an optimal solution. Format, self-correction. Initially, I might forget the floor division in rule A needs to double check the calculation. Careful with rules B, even check after adding 4, yeah. Check primarily after subtracting 7, next multiple of 3, yes, this is the rule D. Check odd even before calculating the move, yes. It self-corrected and self-refined here, and it said, hey, just make sure before I say this is the final result, that I really have an absolute correct understanding of all the mathematical constraints that I imposed on the solution. Nice. Then we have a let's resync phase. If state f path leads to 22, path and button, and the actual is 10, it doesn't change. Exploring neighbor. Pew. Pew. Okay. Okay. Yeah, beautiful. We managed it. Pew. BFN needs a queue, floor, and path string. Yeah, this is the notation. A set of visited floor is sufficient to avoid cycles and redundant work in finding the shortest path. This is an absolute deep understanding of PFS. This is correct. This detailed thinking process covers understanding the problem, selecting the algorithm, simulating it carefully while applying all the rules and constraints, verifying the results, and considering potential pitfalls. This is the first time I see this on any system, and I have tested almost each and every system that is available on this planet on this test. And then we have the official answer. Understanding the problem, BFS, okay. State representation in tools. It says, hey, I'm not just going to try it out. I understand that this is a state, a tuple, and I have here my BFS notation floor path string. So in the floor 5, the path string, you remember FIFO, yes, defining the transition rule as functions. And now it defines here button A, calculate the next floor. If next floor is, yes, beautiful, button B, calculate the next floor, calculate the landing floor, DE. Trap rules, executing BFS, and it starts really with this queue. This is simply amazing. Okay, it took us 90 seconds. Time to first token, 1 second. Tokens per second, 61. But for this, real nice. And we had in total 14K token. So, okay, I want to see this. So I say, show me the complete BFS steps in detail. Thinking, yes. Understanding the goal, recall, yes. Define the rules, okay. ABCD, trap, yes. Execute here, yes. Apply, level 1. Here we go. It really goes through this. Look at this, level 2. It's really going ABCDE, ABCD. It's really going, yes, look, visited. Level, yes, floor 13. Okay, level 4. Need to be careful with trap 22 now. I like this. Okay, we're still in the thinking phase. It didn't even start to print out a final answer. Here we go now. Okay. We have 44 seconds in. He's absolutely doing every single step in language. This is the perfect causal reasoning step. Not allowed, not allowed. Current state. Look, yeah, we have a look at it. Just let it finish. This seems to be absolutely the correct way to do this. Without code. This is just abstract logic. And we're close to 20,000 tokens. 6 presses. Let's have a look at this. I want to see this in detail. Sorry, but no. Level 0. We start here, floor 0, and then we have A, B, C, D, E, or 5 options. So the Q state is now 1A, 3D, 2E, correct. Visited state are, 0 restart, and then we have 1, 2, 3. This is our set of visited state. So let's go to level 1. So we DQ now 1A. Okay, so we at the floor 1, we press A, already visited, we can ignore it. If we press the button B, we have a result. This is 5. This is not visited yet. You see it's not in the visited state. So we NQ now 5. What we have here, and A, B, because we on floor number 5 and we have started with A, and now the button press is B, and we have FIFO rules, so we have 5AB, and this is now the next shortest step, and we have visited at 5. C, cannot use, ignore, ignore. So we have now here from the first dequeuing from 1A, we have 5AB. Current state, we have now finally 5AB. We have all those visited states, so those are all the floors that we have now visited. And then we just go on. Look, DQ5AB. Let's stick with this. So we're in floor number 5, and now we press all the buttons A, B, C, D, E. What happens? A, not visited, so we're in queue now 11, since we're in floor 11, and we have already A and B. And now we press A, so we have now the concatenated string ABA, correct? B, 9, not visited, so we NQ now 9, since we're on floor number 9. We started with AB, we have now the button press B, and we're NQing now ABB. When we add this to the visited floor, C, cannot use, D, ignore, E, ignore. So we have now an 11 ABA and a 9 ABB, 11 ABI, 9 ABB. He is, or whatever this system is, it is amazing. It is absolutely going through this every single step. I mean, I would make a mistake if I would do this manually by hand. I mean, everybody can do this. But this was done in how many seconds? 72 seconds with a verification. Nice. Goal found. Okay, I have to tell you, I am impressed. Yeah, this is the first time I see this. I mean, we could now start code execution, but I think this is done in logical causal reasoning, and it's stable. But you know what? I was like, hey, can you think of any other method or idea how to solve this logic test except BFS methodology? Yes, I want to see what you're thinking. Analyze the problem. Dijkstra graph, A star search, bidirectional, okay. Non-graph algorithm approaches, okay. Dynamic programming, constraint programming. Okay, conclusion, wait. Okay. DFS, of course. Okay, just let it write. Just let's finish this. I would say he found 6 other ways how to solve this. I mean, this is really impressive, no? Okay, DFS, great. Then we have iterative, okay. Educated guessing, well, okay, yeah. Dijkstra algorithm, the classical one. A-star search, the classical one. Constraint programming, okay. Conclusion. For the specific goal of finding the shortest sequence of button presses, BFS remains the most direct, standard, and conceptually simplest algorithm that guarantees optimality for this unweighted graph problem. While other methods exist, they don't either guarantee optimality or add unnecessary complexity for this specific case, like Dijkstra or A-star, or require different programming paradigms, constraint programming. Okay, I would say, yeah, this Gemini 2.5 Pro, yes, real nice, absolutely. Knowledge cutoff is January 2025, so you are about 2 months behind, but I would say not bad at all. But you know what? We have a second logical test. Yes, of course. So let's start fresh. 0 token. I go here with Gemini 2.5 Pro Experimental. And I have here my second test, and you knew this test. This is a test I do now for 11 months on all other things. So let's see if it's able to solve this test, because if it's able to solve this test, I need to build a more complex logical test. But let's have a look. Okay. I don't see right now if it's applying any specific logic chain or any specific methodology to solve this. Okay, just goes here through all the combination, which is nice, but the question is it stable enough that it doesn't make one mistake, not one permutation, not one wrong digit, not one single bit? Will it here stay? We are already at 500 tokens. And here's the answer. Processing the linked queues, Dorn. It gives me here all the reasoning steps and all the clues. Scenario 1, scenario 2. Help! What's happening? Final solution. We have a final solution. You're joking. 10,000. Oh, failed to list tuned more. Yeah, exceeded quota. Never mind. Do we have a summary table? Let's look at this. Phoenix, Brindor, Celestial, Chimera, Dawn, Unicorn, Eldori, Aubergine, Salamander, Healing, Griffin, Alchemy, Dragon. We have a valid solution. 74 seconds. Okay, so what happened here? Help. Okay, let's have a look. Where are we? See. Okay. Let's say we skip here the sorts. Let's see at the solution. So it was thinking for 50 seconds. Okay. And then we have here the answer. So the reasoning process. Sounds like a fantastic challenge. Oh, I like it. Setup. I'll use a table to track the association between the different fields. Beautiful, it's a matrix. Processing the direct clues and simple deduction. Ah, yeah, it's okay. What's simple? Just updates here the table, whatever is immediately available. Processing, yeah. Further deduction. Okay, deduction door. Now it's going step by step through the artifacts. Okay, updating the table. So you see it's filling more and more and more. And it tells us itself, it keeps, if you want, this is a scratch pad. You see, this is what Claude 3.1 Sonnet had with this syncing tool. Notes. This is a scratch pad where it writes here something that is important for its reasoning process that is not part here of the final output, but this is here an internal scratch pad. Nice. Remaining fields and familiar. Now it tries to find the logical path. Go through the logical combination, final check, fill the table completely and review against all the clues. And here we have it. Wow. Here we have now the self-evaluation. Okay. All clues are satisfied. The logic holds. Final solution. Here are the complete association for each wizard and a table. Wow. Okay. I mean, my tests are much too simple right now. I have to increase here the complexity significantly. In the first one, such a beautiful structure, but you see there's a lot of things happening now, and they optimized here this reasoning process here, this test time compute scaling massively, because I have never seen here, as I showed you here, this note field here, where it has its internal, if you want, memory, its scratchpad, where it writes down here what is important for this particular step. So just make sure that it's really not forgetting anything or not overlooking something in the different logical paths. So it writes down the most important and checks before it takes the next steps. Real nice. Okay, what else? So you know me, I say, hey, can you find any other valid solution? Is there any hidden degree of freedom hidden in my instructions? Now you know that this is. Let's look. Potential solution A2, potential path, compare the solution, let's verify this, identify. Okay, here we have an answer. It's a little bit too fast that I can read it in detail, but yeah, let's conclusion, beautiful. So we have, we have a solution 1 as originally presented, okay. Then we have a solution 2 where there is a certain permutation, and we have a solution 3. Excellent catch. This makes the extreme logic test even more interesting, revealing an inherent ambiguity within the clue set. Yes, I did it, my little one here. Let's see. Here starts the answer. Reviewing the critical juncture, step 7 in the previous reasoning. Wizard needing assignment, okay. Let's explore the possibilities for Brindor. Solution 1 possibility. If we have another interlink, subcase 2a, subcase 2b. Yeah, this is exactly the degree of freedom. Nice. This leads to solution 2, and subcase 2b leads to solution 3. Exactly, yeah. Healing on Griffin and Elemental Magic and Pegasus. Not bad. Verification. We already verified solution 1. Let's quickly re-verify the specific constraints in solution 2 and 3. Okay. Solution 2 is valid, solution 3 is valid. Yes, you're absolutely correct to question this. My initial analysis incorrectly assumed the path through possibility 1 was the only one. There is indeed a hidden degree of freedom in your instruction. There are 3 distinct valid solutions. Wow. What else to tell you? Wow. So I know you have a lot of videos already on YouTube where everybody goes here with coding. And I wanted to show you here, what about logic? What about reasoning? What about causal reasoning? Long chain of causal reasoning. Is this system finally able to do it? And I have to tell you, the performance is simply outstanding. So I guess I personally will switch to Gemini 2.5 Pro Experimental 0325. And I just have to tell you, OpenAI, I hope you have your ChatGPT 5 ready to be released real soon, because otherwise, Gemini, Google, you are back. Well, impressive performance. Okay, I think this is it for today's video. I hope you enjoyed it. I hope you had a little bit fun testing it out. I don't know if we have the API prices right now available, but if the API prices are somehow acceptable and not above OpenAI, I think Google has here definitely a winner. I hope you enjoyed the video. Why not subscribe? And I see you in my next video.